So, hi everyone. In the previous video, we have discussed about deadlock, the concept of deadlock and starvation. So for today, for this video, we are going to discuss about the classical problems of synchronization. So the classical na problems of synchronization are a set of well-known problems in ComSci or in operating systems that deal with the issue of coordinating multiple threads or processes that try to access shared resources. So these are the most common problems of synchronization, the bounded buffer problem, or in other textbooks, it's also called as the producer-consumer problem. And then we also have the readers and writers problem and the dining philosophers problem. So this video will be focusing on the bounded buffer problem. Okay, so in the bounded buffer problem, there are two types of threads. So there will be the producer and the consumer. So as I mentioned, the bounded buffer problem is also called as the producer-consumer problem. So from what I have mentioned, there are two types of threads, the producer as well as the consumer. Okay, so the producer and the consumer are using or are sharing a bounded na buffer. So this is the buffer. So the buffer may contain a data. So what the producer does is to generate data and add it into the buffer, while what the consumer does is to take data or remove data from the buffer. Okay, so the problem here is to ensure that both the producers and the consumers do not access the buffer at the same time and that the buffer does not overflow or underflow. So again, what the producer does is to generate data and add it to the buffer. So essentially, it grabs an empty na buffer. So it will look for this buffer, which one are empty, and place an item into that empty buffer. So if there are no empty buffers that are available, then the producer must wait. While the consumer, again, what it does is grab a buffer and retracts the item or takes a data or an item from this buffer, okay? And place the buffer back to the free pool. So if all of these buffers are empty, so the consumer will not be able to get anything. So it has to wait. Okay, so here are the terms that we are going to use. We have the full and then the empty. So as I mentioned, the producer does is to look for empty na buffers or those buffers that do not contain data and put an item into it. Okay, the consumer does, on the other hand, is to look for buffers that are full or those buffers that contain data. So in this case, there are two variables here that we must make use of, or two semaphores actually. So we have the full and the empty. Okay, so these are the semaphores that we are going to use in order to manage the producer, consumer, or the bounded buffer na problem. Okay, so this is the structure of the producer process. So we have a do while na loop here, and then that will of course run while it is true. And similarly, for the consumer process, there is also a do while na loop that will continue looping while it is true. So let us discuss each lines of these codes one by one. So let us start with the producer na process. Okay, so here is the producer process wants to produce an item, okay, in one of the empty buffers. So what it does is to use the wait operations, okay, and it must wait until the empty na semaphore is greater than 0. So essentially what happens is it must look for empty na semaphore. So if the empty is equal to 0, that means that all of these buffers are not available or already containing data. So it must make sure that the empty na buffer is greater than 0. So what it means is if the producer wants to produce something, it first has to check if there are empty slots in the buffer. So if it has successfully inserted na something into the buffer, then the number of slots must be reduced. Okay? And it also must wait for the mutex. So the mutex na semaphore here, so note that is empty, and then the mutex are all semaphores that are integer na variables. Now, once it has successfully inserted na something, right, into the buffer, then it must decrease the number of slots or decrease the number of empty. So then it acquires the lock to make sure that no other processes will be modifying empty. And it adds item into the buffer. Okay? And after that, it signals the mutex or releasing the lock, and to signal that it is done adding the item into the buffer. And then after that, it sends a signal to the full and essentially incrementing the full na variable to indicate that the producer has added one data into the buffer. So adding one data increases the value of full. So if we go back here, if the producer has successfully inserted a data here, of course, the empty will be decreased and then the full will be incremented, okay? Or be increased by 1, right? So now we are done discussing the producer na process. Let us move on to discussing the consumer na process. Okay, so on the other hand, for the consumer, it must wait until the full is greater than 0, and in order for it to decrement the full. So essentially, di ba, going back here, what the consumer does is to grab data from this buffer. So it must make sure that the full is greater than 0, because if this full is equal to 0, and that means that the empty is 5, that means that there is no data in the buffer. So it must wait that the full is greater than 0 to ensure that there is at least one buffer that contains a data. Okay? Yeah. So if full is equal to 0, it means that there are no slots in the buffer. And if full is greater than 0, the full is decremented because the consumer consumes data and removes data from the buffer. And it also makes use of the mutex na semaphore to acquire and to release the lock. So this is just to make sure that no other processes are removing an item from the buffer. Okay? So para since nasa critical section siya. And now, after removing an item from the buffer, it signals the empty na variable. So in the empty na variable, it essentially increments the empty. Okay, since it has successfully removed one item, so there will be one buffer that will not have a data. So that means that the empty na variable will also be increased. Okay? So yeah, let us have to try a simulation. So essentially, we have two semaphores, full and then empty. And the full semaphore is initially having a value of 0. And that means that there are no buffers that contain any data. And the empty will contain n. And in this case, we have 5 since we have 5 buffers that are empty. Okay, so first is the producer wants to do something. Oh, this is supposed to be consumer, not producer. Sorry, let me just change that. Okay, this is supposed to be consumer. Okay, so please don't be confused if you see another producer here. Oopsie. Wait a minute, let me just change it. I had an error. This is supposed to be the consumer. Okay, I'm done. Okay, the other one is correct already. So let us go back here again. We will try to have a simulation. Okay, so this is the structure of the producer process, and this is the structure of the consumer process. So I have discussed this in the previous slides. Okay, so initially we have two semaphores, full and empty, that are initialized with values of 0 and 5. That means that the buffer is still empty, so there is no all of the slots are available, and the empty is 5. That means that all of the buffers are empty. Okay, there are 5 buffers that are empty. Now, the producer wants to add an item into the buffer. So first, it checks if the empty is greater than 0. Okay, so since it is true, because we still have 5 slots that are available or that does not contain any data, then it will proceed. Okay, and it waits for the mutex or locks it, acquires the resource, and it adds item into the buffer. Okay, and locks the mutex or locks the resource, releases the resource, and then next is signaling the full. So that signaling the full, that means incrementing 1 to the full na variable. So since you can see that there is already data that is inserted here, that means that we have 4 empty slots and 1 buffer that is full. Okay, now assuming that there are no empty slots, assuming that the producer has already inserted a lot of data. So all the full is now 5. That means that 5 buffers are unavailable or are containing data. So the empty is also 0. So the empty, again, in this part is it checks if the empty is greater than 0. So in this case, naging false siya because there are no empty na buffers. So it must wait. Okay? So, yeah. What about the consumer? Now, what the consumer does is to grab data from the buffer. Okay? So, ito naman yung process niya. So, it must wait for the full. It must wait by making use of the full na semaphore. So, it checks if that full na semaphore is greater than 0. Okay? That means that essentially checking if there are any buffers that have a data. Okay, so if it is greater than 0, then it decrements the full na variable and removes an item from the buffer. And as you can see here, now we have 4 na buffers that are containing data and the rest that are empty. So it also reflects here on the value of the full and empty semaphores. And then signals the empty, essentially increasing the value of empty by 1, since there is now 1 buffer that is available. Okay, and it consumes the item in the next na consumer. So assuming that that all slots are empty. Okay, all of the slots are empty. So, and the consumer wants to grab a certain data, and it checks if the full is greater than 0. Okay, so it must wait for the full na variable, and it results to a false. Okay, because the consumer cannot grab any data because essentially these are all empty. So it has to wait until the producer gets to add item into the buffer. Okay. So in the next video, we are going to discuss about the readers and the writers problem.